In this video, we're going to look at a pretty difficult exam question that combines logarithms with cubic polynomials. So just to start with, we know that we're going to have to eventually use the log rules. And the two log rules that we're going to use here is the fact that when the base is the same and you're subtracting two logarithms, such as log base a of x, take away log base a of y, you can combine these two logarithms by saying it's the division of the insides of the logarithms. On top of that, you can use the rule that log a of b to the power of c can be written as c log base a of b. So basically, you can bring the power forward as a coefficient in the same way that you can bring the coefficient forward as a power again. So let's have a look at how we're going to use these two rules in this question. So to start with, I'd advise you to just pick and use any rule that you can. For example, in order to simplify this and combine logarithms, we can't have a 3 before the logarithm. So let's take that coefficient as a power, just to start with. Let's then take all the terms with log to one side and all the terms that don't have log, let's leave them on the other side. So here we're going to subtract log base 3 of 14x minus 25 from both sides. When you do that, the left hand side becomes log base 3 of everything that was already on the left hand side. Take away log base 3 of 14x minus 25. And then you can make all of that equal to 2. Now, when you're subtracting logarithms and the base is the same, you're dividing the insides of the logarithms. So we can say that the left-hand side can become log base 3 of 2x minus 1 all cubed divided by 14x minus 25. And you can say all of that is equal to 2. Now, when you're dealing with logarithms, I'd always recommend my students to write out this template. If 10 squared equals 100, then log base 10 of 100 is equal to 2. It tells you the positioning of where things are rearranged in logarithms. It tells you the base comes forward, just like the 10 comes forward. What's on the other side becomes a power and becomes equal to the inside of the logarithm. In this case, you bring the base of 3 forward, you take the 2 as a power on the other side, and you make that equal to the inside of the logarithm. So that's 2x minus 1 all cubed, all divided by 14x minus 25. Now, what is 3 squared? Well, any number squared is just that number multiplied by itself. So 3 squared is just 9. Let's now multiply both sides by 14x minus 25. 9 times 14x is 126x. 9 times minus 25 is minus 225. And all of that is equal to 2x minus 1 cubed. When you cube a bracket, what you're essentially doing is you're multiplying it by itself 3 times. So I'm going to write this out as 3 individual brackets. We're going to leave the first bracket as it is. And with the last two brackets, well, 2x times 2x is 4x squared. 2x times minus 1 is minus 2x, and also minus 1 times 2x is minus 2x again. The reason I wrote them on the top is because you can collect the like terms and make that minus 4x. Minus 1 times minus 1 is plus 1. Once you reach this position, you want to then expand out the brackets again. This time 2x times 4x squared is 8x squared. 2x times minus 4x is minus 8x. 2x times 1 is plus 2x. And now complete the rest. You know how to expand, I'm sure. Minus 4x squared plus 4x minus 1. Let's now collect like terms and join them together here. Sorry, this first time is supposed to say power of 3. I miswrote that. So it should be 8x cubed minus 4x squared. Oh, sorry, I just realized now. 2x times minus 4x should also be minus 8x squared. And when you combine that with minus 4x squared, that will give minus 12x squared. 2x, I'm just going to double check that. Yeah, I did that correct. And then plus 4x is equal to 6x. So plus 6x. And then we have the minus 1. Let's sort of close this off just so we don't get confused with all the other algebra. What you then want to do is take all the terms to one side. So let's take away 126x and let's add 225 to both sides to make the left hand side equal 0. When we do that, the right hand side becomes 8x cubed as it was minus 12x squared because the x squared term is unchanged. Now 6x take away 126x is minus 120x. Yeah, because 6 take away 126 is minus 120. Minus 1 take away plus 225 is plus 224. And then now to get from what we have to the final answer, we notice that, well, each of these terms are multiples of 4. And the reason I picked out 4 is because, well, to go from 2x cubed to 8x cubed, that's the difference of a multiple of 4. Let's divide each term by 4, and that should give you the final answer here. 8x cubed divided by 4 is 2x cubed. Minus 12x squared divided by 4 is minus 3x squared. Minus 120x divided by 4 is minus 30x. And 224 divided by 4 is plus 56. So all of that is equal to 0, and it matches part A of the question. So that's done. Let's now move on to part B of the question. Now with part B, we're going to use a very important rule. And before we do, I'm just going to change the thickness of this pen. So how do we show that this is a root of the cubic? Well, sorry if you can't see this, but it's this cubic here. To show that, you want to substitute x. Let's let f of x equal this. If you manage to show that f of minus 4 is equal to 0, that means that x equals minus 4 is a root of this cubic. So let's do that. 2 lots of minus 4 all cubed, minus 3 lots of... So I'm just substituting minus 4 into this whole expression, and it should work. It should all equal 0. Plus 56. So minus 4 cubed is minus 64, times 2 is minus 128. Minus 4 all squared is 16, times minus 3 is minus 48. Minus 30 times minus 4 is plus 120, plus 56. And yes, that all does equal to 0, so that's good. That means x equals minus 4 is a root. Now, since we know that that's a root, that means that x plus 4 must be a factor. That probably has some use, so let's look at part C of the question where I'm sure it will be useful. So it says, hence, using algebra, solve this. Well, solving this expression is the same as solving this expression because we've shown that they both can be rearranged to the same variable. So what we're going to do now is divide this whole cubic, by a factor that we know definitely goes into it, which is x plus 4. So let's do that. I'm going to write up a big bracket, 2x cubed minus 3x squared minus 30x plus 56, all divided by x plus 4. Okay, let's have a think about it. So to go from x to 2x cubed, you have to multiply 2x squared. So 2x squared times x is 2x cubed. 2x squared times 4 is a positive 8x squared. Now we're going to subtract, and when you do that, minus 3 take away 8 is minus 11, so we're left with minus 11x squared. Remember to pull this term here down, minus 30x, and then repeat the process. So to go from x to minus 11x squared, you multiply minus 11x. Repeat that again, minus 11x times x is minus 11x squared. Minus 11x times 4 is minus 44x. Subtract all of that. You get the x squared terms cancel out, and then minus 30x plus 44x is equal to 14x. And then you pull down this last term here, so plus 56. Now to go from x to 14x, we'll just multiply 14. And then 14 times 4 is 56, and that will all cancel out to give you 0. That means that this whole cubic can be split up into x plus 4 multiplied by this quadratic that is formed. So that's 2x squared minus 11x plus 14. And what we're now going to focus on is factorizing this quadratic here. Quite a long question. So 2 times 14 is equal to 28. What 2 factors of 28 multiply to give 28 and add to give minus 11 is actually minus 7 and minus 4. What I then do is put these in our brackets with 2x because that's the number before x squared. You may have a different method, that's completely fine. And then after you've done that, after I do that, I simplify both brackets as much as possible. So nothing goes into 2 and 7, so we just leave this first bracket as it is. Whereas the second bracket, both the terms are multiples of 2, so we can divide each term by 2 to get x minus 2. So just in general, this whole cubic can be split up into x plus 4 multiplied by this whole quadratic here, which can be simplified into this times this. Now, because it is asking us to solve, and we know the inside of a logarithm can never be negative, minus 4 is not a valid solution. However, if we make this equal to 0, so we know x equals minus 4 is not valid, but x equals 2, which makes the second bracket equal 0, is a valid solution. Because if you put that inside of the logarithms, they'll give out positive values. Same with x equals 7 over 2. So these are your two final correct answers. Hopefully that all made sense to you guys. If you guys do have any questions, just let me know in the comments. Otherwise, be sure to like the video if it helped and subscribe. Thanks for watching.